For state Faraday law of electromagnetic induction. So electromagnetic inductions of Faraday law of electric induction state that induced EMF is proportional to the rate change of flux, right? So this is induced EMF or voltage, and this is flux, and this is dt, meaning this here is the change of flux, the rate change of flux. So this is the Faraday law. And the second is Lenz's law. So if you relate the Lenz's law to the Faraday law, Faraday said you can induce EMF or voltage or current in the circuit, right? If you have the rate change of flux, but the induced EMF or induced current I is always right here, induced current or induced voltage or EMF, right? V is always oppose that the currents or initial current produce it. Meaning you have let's say you have the solenoid here, right? And this is the current flow. When the current flow in the solenoid, so you produce the flux linkage in the solenoid, and the current is changed at the time t. When the current changes, meaning you have a increase or decrease B. If you have a increase or decrease B, meaning you have the change of flux. The change of flux in the solenoid induce or produce the new current. Let's say I use a new current, right? Or induced current that's oppose the current that produce it. Meaning you have a current, initial current, this is I1, and the second current is current induced because of, according to the Faraday law, the change of flux at the time t, you produce EMF, voltage, or you produce current, right? Number 4b, a coil of 16 turns and cross-sectional area 4.65 exponent minus 4 meters squared is placed in a uniform magnetic field 0.8 Tesla. The plane of the coil is perpendicular to the field. So if you draw the diagram here, so let's say you have the coil here. This is coil with the number of turn of 60. This is N, and you have a magnetic field, right? Magnetic field, right? B, right? And the situation here is the plane and the coil is perpendicular, so meaning the angle between so now with the perpendicular, meaning the angle, if you write the diagram here, meaning the coil and the B is parallel, right? So if you have the coil here, the same coil, 60 turn, and I write the rectangle perpendicular, meaning the direction of the B is into the page. So meaning the area of the area A and B is 90, this is angle of the coil and the coil C and the magnetic field B is 90 degree, but the area here, A, angle A and B is 0. So the question number 1 is total magnetic flux. Number 1, magnetic flux is given by the equation BA cos theta. So the B here, so you have a number of turn. This is time, right? Because number of turn and BA cos theta. So when the coil and perpendicular, so meaning the theta here is equal to 0, right? 0 degree. So 0 degree is equal to 1. So number of turn is 60. So this is 60, and B 0.8 Tesla, and the area A, cross-sectional area A is 4.65 exponent minus 4. So you can find the value of the flux here is equal to, so right here, 0.022 Weber, right? So this is answer. You can use the calculator. So number 2, calculate average induced EMF generated in the coil if magnetic field reduced. So if the change of magnetic B here, or B here, so meaning you can relate to the induced EMFs because of change, this is negative, right? Change of flux, right? So the change of the flux is here from the initial is is 0, right? Initial is 0.8. So this is sorry, 0.8 test 0.8 is a B. So the flux initial is 0.22. Final is 0 minus initial is 0.022, and in the time t in 0.5 seconds. So you can produce EMF. So EMF is equal to 0.044 volt. So sketch diagram to show the direction induced current in the coil with respect to the direction is based on the condition in 4B2. 4B2. So I think the diagram is here. This is question number 3.